All right, so we're going to start with a couple of review problems to get warmed up. So please take out your paper, your spare paper, and let's write these problems down and work through them together. So I'm going to give you a couple of matrices to get started. All right, so let's see. First of all, let's do 2A plus B. So here are our matrices, and we're going to do 2A plus B. Now, before you get too far into this, the first thing you probably ought to figure out is, are you even going to be able to do this problem? Are these matrices going to be able to be added? Well, what's the rule for addition? You remember? In order to add matrices or subtract matrices, they have to have exactly the same dimensions. So, what are the dimensions of matrix A? 2 rows, 3 columns, 2 by 3. Remember, rows of the bleachers, columns of the White House. Rows go this way, columns go this way. So that's a 2 by 3. B is also a 2 by 3. So since they are both 2 by 3s, we are going to be able to add them. So since the problem is 2A plus B, we're going to double A. So we're going to take 2 times everything in A. So 2 times every entry. And then we're going to add B to it. And, uh-oh, the dog's in the way. Come on, dog, get out of the way. Yes, that's a good girl. So now we're going to add them together, and we're going to end up with, okay, here we go. Remember, you add corresponding entries. So that's going to be 1, 9, 13, and 8, 9, 20. So remember, when we add matrices, we add corresponding positions. So for example, this number gets added to this number, and that's where the 9 came from. And there we go. All right. The next question, I'm going to stick with these 2 matrices, and the next thing I want you to do is multiply them. All right, we're going to continue talking about multiplication today, but we started it yesterday. Can these matrices be multiplied? Can we do A times B? Well, again, it comes down to the dimensions. Here are the dimensions of the 2 matrices. What is the rule for multiplication? In order to multiply them, these 2 have to match. They don't. So therefore, you cannot multiply these matrices. They are not able to be multiplied. Then the third question I want to ask about this is, I want you to figure out what this is. Now, do you remember the little b indicates you're to be looking in matrix B, right here, and you're looking at the entry that is in the second row, third column. So the second row, third column, so that would be 8. So the answer to that question, B sub 2, 3, is the entry in matrix B that is in the second row and the third column. All right, one more review question. And remember, you can go back and do these review problems as many times as you wish. One more, we're going to solve a little system. And we're going to use substitution. Now, in the real world, you can substitute or eliminate or do about 10 other different things, but right now we are just going to substitute. So, pause for a moment. What does that mean? That means you have to get one of your variables by itself. So I would suggest you either get this one by itself or this one by itself. Don't get one that's got a number hooked to it. That means you're going to have fractions. It's just going to be a mess. So I'm going to go ahead and use that top equation because it's extra special. Because there's a 0 in it, that makes it easy. So x equals 3y. So that top equation says x equals 3y. Now, I'm going to take this value of x, and I'm going to plug it in right here. So that's going to go right here. So now I'm going to have, this equation is going to say 4 times 3y plus y equals 13. So 12y plus y equals 13. So 13y equals 13 and y equals 1. Now, if y equals 1, I can go back and plug in anywhere. I can plug in any of these equations to get my x value. Remember, my answer is where these two lines are intersecting each other. So if I let y be 1, it looks like x is 3. So the answer to the question is 3, 1. Okay, that's it for review. Now we're ready to pick up where we left off in our notes, which is section 7.2, problem 2D. So we're still doing some more matrix multiplication. We know the rules. Yesterday we went through the process. So we're going to go through some more. So we're going to multiply matrix D, which is 1, 1, 3, negative 2. This is D. I'm doing DG. And then matrix G, which is 1, 2, 3, negative 3, 1, 0. So I am multiplying, this is problem 2D in my notes. I am multiplying matrix D times matrix G. Now, remember we talked earlier about how we tell if we can even multiply, because sometimes we can't do it. So the dimensions here, 2 rows, 2 columns. The dimensions here, 2 rows, 3 columns. These match. That means that we can multiply. This problem is going to be multipliable. And my answer, I'm going to try to squeeze it in here, my answer is going to be a 2 by 3. So it is going to have 2 rows and 3 columns. So remember, 2 rows, 2 columns for the first one, 2 rows, 3 columns for the second one. These two must match. They do. These two give me the dimensions of the answer. So my answer is 2 by 3. 2 rows, 3 columns. Now I'm going to start filling in these numbers. Now remember how that works. For this guy right here, he is in the 1, 1 spot. That is the first row, first column. First row, first column. So I'm going to write down the numbers in the first row, which are 1 and 1. And then I'm going to write down the numbers in the first column, which are 1 and negative 3. Now take a moment and see how I did that. It's very organized, very systematic. It isn't hard at all. You do the same process every time. I wrote down 1 and 1, and then 1 and negative 3. Now I multiply and add those. So that's going to be 1 minus 3. So that's going to be negative 2. 1 plus negative 3 is negative 2. All right, now what spot is this? This is the first row, second column. First row, second column. So now I'm going to multiply the first row times the second column. So I'm going to write down the numbers in the first row, which are 1 and 1. There they are. And then the numbers in the second column, which are 2 and 1. So 1 and 1, 2 and 1. So I'll multiply each pair and then add them up. So 2 plus 1 is 3.
Stop. No.
And then finally, I've got this guy, which is in the first row, third column. First row, third column. So now I'm going to multiply my first row, which is still 1, 1, times my column, which is 3, 0. So 1, 1 times 3, 0. And so that's 3 plus 0, that's another 3. Well, now we're ready for the second row. So keep in mind, this is second row, first column, second row, second column, second row, third column. Again, those numbers are not magical. Those numbers are very straightforward. This is the second row, this is the first column. So second row, first column. So to do that, I'm going to have to multiply the numbers in the second row times the numbers in the first column. So second row, first column. There they are. The numbers in the second row times the first column. So 3, negative 2. Write down the numbers in the second row. And then the first column, 1, negative 3. Now multiply each pair and add those together. So we have 3 plus 6, so that's going to be a 9. That's 3, that's 6. Add them together, we get 9. Now I'm going to second row, second column. So again, I've got my 3 and my negative 2, but now I'm multiplying it times 2 and 1. So 3, negative 2 times 2 and 1. So that's 6 minus 2, that's 4. And finally, that last spot, which is second row, third column. So second row and third column. And that looks like another 9. So there we go. You have multiplied the matrices. Okay. Let's try the next one. The next one says G times E. All right, so G times E. While I'm erasing and getting set up, why don't you start figuring out if it's even going to be doable? Because remember, sometimes we can't even multiply these things. So is G times E even going to be possible? This is matrix G. I'm doing problem E. This is matrix G. And this is matrix E, if I've copied it correctly. And I'm going to see if I can multiply them. So what are the dimensions here for matrix G? Well, it has 2 rows and 3 columns. 2 rows, 3 columns. Good. What about this matrix? It has 3 rows and 3 columns. Now, obviously, those aren't the same dimensions, but these match, and that's all that matters when we multiply. So we are going to multiply these two, and the answer we get is going to be a 2 by 3. So we are going to get a matrix that has 2 rows and 3 columns. All right, so here we go. We're going to start multiplying. we're going to fill this spot right here, which is the 1, 1 spot, first row, first column. So we're going to multiply the first row times the first column. Now, don't panic. There are more numbers than usual, but this is not a big deal. Write down every number in the first row. 1, 2, 3. Then next to those, write the numbers in the first column. 1, 1, negative 1. So I wrote down 1, 2, 3, 1, 2, 3, and then 1, 1, negative 1. Now I'm going to multiply each pair and add them up. So 1 plus 2 plus negative 3. So that just works out to be a 0. Add those up. That just gives you 0. All right, next spot. And you can go in whatever order you want. I'm just trying to be organized here. I'll do this one next. It's in the first row, second column. So I'm going to write down my first row. And now I need my second column. So that's going to be this set of numbers now, the second column. So I'm going to write that set of numbers down next to here. So negative 1, 2, and 1. So we have negative 1 and 4 and 3. Negative 1 and 4 and 3. So that adds up to 6. Okay, getting the hang of it. Now we're going to go here, first row, third column. So first row, third column means I'm going to write down my 1, 2, 3 again. And then I'm going to write down my third column, which is 0, 3, 4. So I got a 0, a 6, and a 12. So that's 18. And the top row is done. Now the bottom row, here, this is the second row. So this is the second row, first column, second row, second column, second row, third column. And now I'm going to have to use that second row to do my multiplication. So here's the second row, and I'm starting with the first column. So second row, first column. So I'm going to write down my negative 3, 1, 0, and then 1, 1, negative 1. I'm going to add those up. So let's see, that's negative 3 and 1 and 0. So negative 3 plus 1 plus 0 is negative 2. Moving on to the next spot, we want second row, second column. So negative 3, 1, 0, that's my second row. And then negative 1, 2, 1. All right, let's see. That's a positive 3, a positive 2, and a 0. So when I add all that up, positive 3, positive 2, and 0, I get a 5. And finally, one more. We need the second row. And then we need the third column. We're now over here. So we need the third column, which is 0, 3, 4. So 0, 3, and 0. So that number is just a 3. And we have multiplied G times E And this is your answer. This matrix is your answer. Oops. We got one more. Now we got to multiply F times G. F times G. Okay. All right, so again, while I'm getting everything erased here, why don't you see if you can even multiply F times G? So examine the dimensions of F and G and see if it is possible to multiply them. So F is negative 1, 5, 3, 0, and G is 1, 2, 3, negative 3, 1, 0. So we want to know, is it even possible to multiply F and G together? What are the dimensions of F? This is F right here. What are the dimensions? 2 by 2. 2 rows, 2 columns. What are the dimensions of G? 2 rows, 3 columns. Oh my goodness. We can indeed multiply, and the answer will be another 2 by 3. So 2 rows, 3 columns. 2 rows, 3 columns. All right, I'm going to go through this step by step. I think most of you have probably gotten this figured out by now. So if you want to fast forward to the answer and check yours, that's absolutely great. But I'm going to go ahead and go through it step by step. So I need to fill all of these positions. This is the 1, 1, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column. So that's my little key to tell me what I'm multiplying. So I'm going to start by multiplying my first row times my first column. So negative 1, 5 times 1, negative 3. So I'm going to add those together. So negative 1 and negative 15, I'm going to get negative 16 for that spot. Then I'm going to take my negative 1, 5, and I'm going to multiply it times my second column, which is 2, 1. So I get negative 2 and 5. That's 3. And then I'm going to take my first row again, and I'm going to multiply it by my third column. 3, 0. Multiplying that's going to give me a negative 3 plus 0, so that's just going to be negative 3. Now I'm going to move on down to my second row. I'm going to use my second row now. And I'm going to multiply my second row, which is the numbers 3 and 0, times the first column, which is 1, negative 3. Second row, first column. And that's 3. 3 plus 0. And then I'll take my 3 and 0, my 3, 0, and multiply it times my second column, 2, 1. That's 6. And then finally, my second row times my third column. And there we go. That is the answer to F times G. And that takes care of matrix multiplication. So now we're going to move on to part 3 in your notes, which is evaluating determinants. So let me get this erased so I can write that word down for you so you can see what the word is. When you see a matrix, but it is not with the brackets, it's got these vertical bars. They look like absolute value, don't they? When you see that, that tells you that you are evaluating a determinant. Okay, we're evaluating a determinant. A determinant. Now, one thing to remember with determinants is that you must be square. If you're going to have a determinant, if you're going to be able to calculate a determinant, the matrix has to be square. So let's go back, review a minute. What does it mean to be a square matrix? It means that you have the same number of rows as columns. So this has 2 rows and 2 columns. So this determinant can be calculated. And it is very, very easy to do that. To calculate this determinant, you start right here. Look where my finger is, please. I start right here. And I multiply these 2 numbers on this diagonal. So I multiply 1 times 4. And then I multiply the other diagonal, 3 times 2. So I always start here. This is important. Pay attention. I start here. I multiply 1 times 4. And then I multiply 3 times 2. And then I subtract those. So it's 1 times 4 minus 3 times 2. So the answer to this would simply be -2. 4 minus 6. -2. That is all there is to evaluating a 2 by 2 determinant. So let's look at B. When I say 2 by 2, I mean it has 2 rows and 2 columns. Perfect. Now I'm going to evaluate it. So what did I just tell you? Start right here. Always, always, always look where my finger is. Please start here. Multiply. So that's going to be 2 times 7. Multiply. 3 times -1 and subtract. So this one is 14 minus -3, which is 17. So the value of this determinant is 17. Determinants have lots of uses. We're going to talk about a couple of those uses later on, but right now we're just calculating them. So when you see these vertical bars that look like absolute value, that means, oops, calculate me, I'm a determinant. 14 minus -3. Okay, there's one more. Hopefully you've got this one done maybe already. I think I'll try to squeeze it in right here. We're going to evaluate -1, 4, 2, 3. So again, remember where you must start. You must start right here. So we're going to have -1 times 3, 2 times 4, and we're subtracting them. So -3 minus 8. So the answer would be -11. -11 for that determinant. Hopefully you are all A-okay with that one. We're going to go ahead now to the next size up, which would be the 3 by 3. Remember, the matrix has to be square. So 2 by 2, the next logical step would be 3 by 3. There isn't anything in between. And the step after that would be 4 by 4, which we are not going to do by hand. We might do those on our calculators, but we're just learning 2 by 2s and 3 by 3s. So here we go. This is a little bit different, so bear with me. All right, so we're going to evaluate this determinant. First thing I want you to do is to take the first 2 columns and reproduce them over here on the, what would be the right side of the matrix. So when I say columns, I mean 1, 0, 1, there it is. 2, -1, -2, there it is. Make sure when you recopy these columns, these are the columns that you are recopying. Be sure when you recopy them that you are, these 2 columns right here, be sure when you recopy them that you are including negatives. All right, so here we go. Pay attention. Easy, very easy. Start right here, like always, like before, and I want you to multiply these three numbers together. So look at what I did. I'm drill line through them. We're going to multiply those three numbers together. So 1 times -1 times 1, that is -1. Now, step over one step and multiply these together. So multiply 2 times 3 times 1, we get 6. And then one more time, multiply these together, and we get 0. So I multiplied these, I multiplied these, I multiplied these. Now I'm going to add them up. 5. Add them up. Just total them up. -1, 6, and 0. Add them up. Now guess what you're going to do? Now you're going to do exactly the same thing in the other direction. So now we're coming down here, and we're going to multiply these together. So that's a 0. Remember, anytime you multiply by 0, you get 0. Now we're going to multiply these together. -6. Now we're going to multiply these together. 0. And then I'm going to add those numbers up. So I got 0, -6, 0. I'm going to add those up, and I get -6. So now when I did all of these, I got a grand total of 5. When I did all of these, I got a grand total of -6. Now take those two numbers and subtract them. So 5 minus -6. Subtract them. This minus this. So the answer to the question is 11. The value of the determinant is 11. Now, some of you are thinking right now, oh my gosh. Oh, just don't panic. This is easy. You'll get the hang of it. Not complicated at all. So let's move on to the next one. I have to erase this one. Remember, the joy of video is you can go back and replay it. So now we're doing E. I'm on problem 3E now. So I have 321, 140, and -213. Okay? We're going to evaluate this determinant. So look back at your notes. So think about what we just did. What's the first step? Well, the first step is to recopy these two columns right here. So recopy them exactly. So 3, 1, -2, and then 2, 4, 1. So 3, 1, -2, 2, 4, 1. Recopy them. Just the first two. All right, now we're going to start multiplying. So we're going to start right here always. Guys, this is really important with all your determinants. Please start here always. So we're going to start here and we're going to multiply. So 3 times 4 times 3 is 36. And then we're going to multiply here. That's just going to be 0. And then we're going to multiply here, and that is 1. So 3 times 4 times 3, 2 times 0 times -2, 1 times 1 times 1. Now I'm going to add them up, and I get 37. And you're not done. Now we got to go back and go the other way. So now we're going to go this way. Multiply, I get -8. Multiply, I get 0. Multiply, I get 6. So -2 times 4 times 1, 1 times 0 times 3, 3 times 1 times 2. Add them up. -2. To get your answer, you take the first one minus the second one. So the answer to this problem is 39. 37 minus -2. 39. Okay. One more. Why don't you go ahead and get started on problem F while I am getting erased and copied down and everything. See if you can figure out the value of the determinant for problem F. If you're stuck, listen to me. If you're not stuck, mute me and do it on your own. We're going to recopy the first two columns. And we're going to start multiplying right here. So that's a 0. That's a -8. And that's a 12. So I'm multiplying this diagonal, all these numbers, and I get 0. Multiply all these numbers, I get -8. Multiply all these numbers, I get 12. Add them up. 4. Not the answer. Got to go the other way now. So we're going to multiply these numbers. That is 18. And then these numbers are 2. And these numbers are 0. Add them up and we get 20. So these give me a positive 18, a positive 2, and a 0. Now the final answer is 4 minus 20, -16. The final answer is always the first answer you got minus the second one. So it's these answers minus these answers. So the answer is -16. That is pretty easy, isn't it? All right, so now we're ready to find the inverse. The notation, if you're looking now at problem set 4 in your notes, the directions say find A inverse. Remember, that means the inverse of A. You're finding the inverse of A. That's what that notation means. The inverse of A. All right, so how does this work? Now, I know you're probably thinking, oh my gosh, I have to learn something else. Yes, you do. The nice thing is all of these things have a definite step-by-step process. You just have to practice enough to be able to remember the process. So, to find the inverse, we have to do two things. The first thing we have to do is find the determinant. So step 1 is find the determinant. So the determinant of A, we just practiced this. Who remembers? How do we find the determinant of this matrix? We multiply 1 and 5. We multiply -1 and 2, and we add them up. So the determinant, no, we don't add them up. Oh my goodness, we subtract them. Oh my gosh. We multiply 1 times 5. We multiply 2 times -1, and we subtract those. That's how we find the determinant of a 2 by 2. So let me say that one more time. We multiply 1 times 5. We multiply -1 times 2, and we subtract those. So this determinant is going to be 5 minus -2, so it will be 7. 5 minus -2, so the determinant is 7. That's step 1. Finding the inverse is a 2-step process. The first step is find the determinant. Okay, now the second step is we're going to build a new matrix. And the new matrix is really easy to build. Watch this carefully. We take these two numbers right here. Look where my fingers are. These two numbers. And we switch them. So the 5 goes here and the 1 goes here. Now there are reasons for all this, but we're not going into it. Just take these two numbers and switch them. Then the other two numbers, so I just did these two, I just switched them. These other two numbers change their sign. So that's a positive 2, make it a negative 2. That's a negative 1, make it a positive 1. So these two physically get switched locations, and these two get to stay where they are, but their signs change. So now we have the determinant, we figured out what the determinant was, and we have built a new matrix. The inverse will be this new matrix with every number divided by the inverse, or by the determinant. Every number divided by the determinant. So just take this new matrix that you just built and divide each number by 7. The determinant. Whatever your determinant is, take your new matrix and divide each number by that. So this is the inverse of the original matrix. It's a lot to digest, I know. Let's review the steps real quick before I erase and we do another one. The first thing we had to do was find the determinant. So we took 1 times 5, 2 times negative 1, and subtracted those, and we got 7. Then we built this new matrix by taking these two and switching their places, and these two and switching their signs. And then we took those new numbers that we got and divided them all by the determinant. And that is how we got the inverse, which is full of fractions, which is fine. That's how it is. Let's try the next one. So here's our matrix. 1, negative 3, 0, 4. And we're going to find the inverse. So the inverse is going to be a new matrix. We just got to figure out what it is. Okay, so remember, it's a two-step process. First step, we're going to find the determinant. So to find the determinant, we start here. We take 1 times 4. We take 0 times negative 3. And we subtract them. So 1 times 4 minus 0 times negative 3, so we get 4. So the value of our determinant is 4. Now, remember what step 2 is? We make our new matrix. And how do we make our new matrix? It's really simple. There's no math involved. We take these two numbers, look where I'm pointing, and we physically flip-flop them. So 4, 1. Then we take these two right here and we change their signs. So this becomes a positive 3. And since that's 0, it just stays 0. 0 doesn't have a sign, so I can't really change it. So these two get flip-flopped. That becomes positive. That would change sign, but since it's 0, it just stays the same. Now, I take this new matrix, and every single number in it gets divided by the determinant. So I'm going to reduce any fractions it can reduce. So for example, that's going to be a 1, 4 over 4, then 3/4, 0, and 1/4. And there is the inverse. So, guess what? There's another one. So, let's try this one now. Same thing. We're finding the inverse. Don't you dare tell me this is boring. The only way to get good is to practice, so we're just practicing. We're going to find the inverse now of this matrix. So, who remembers what step 1 is? I know some of you out there are talking. Some of you out there are saying, find the determinant. So here we go. 2 times 3, 4 times -1, and subtract them. So 2 times 3, 4 times -1, and subtract them. So that's going to be a 6, actually plus 4, that's going to be 10, because it's 6 minus a -4. 6 minus a -4, so the determinant is 10. And then we need our new matrix. This is step 2. Remember, finding the inverse is a 2-step process. But finding this new matrix is really easy. Take these 2 right here. Look where I'm pointing. These 2 right here. And flip-flop them. So we're going to put 3 here and 2 here. These get flip-flopped. Inside that one becomes a +1. And that one becomes a -4. So these 2 switch. That becomes a positive, that becomes a negative, because whatever they are, they switch sign. So if they're positive, they become negative. If they're negative, they become positive. And then we take that new matrix and we divide each of the numbers in it by our determinant, reducing any fractions that we can. So the new matrix, that would be 3/10, 1/10, -2/5, and 1/5. And there is your inverse. You're thinking, oh my gosh, I can't stand anymore. Yes, you can. You have one more. So now we're going to find the inverse. One more. So we have matrix is -1, 4, and 2, -8. Okay, we're going to find the inverse. So here we go. What do we do first? First, we're going to find the determinant. Yep. So what is the determinant of A? See, it'll be -1 times -8, 2 times 4, and subtract them. So -1 times -8, 2 times 4, and subtract them. Uh-oh. Uh-oh. Did you get 8 minus 8 or 0? Why is that bothering me? Can you think about it for a minute? Think about what the next step is. The next step is to build a new matrix, right? But then what do we do with the numbers in the new matrix? Don't we take all the numbers in the new matrix and divide them by this? Can we divide by 0? Is division by 0 ever allowed? So are we going to be able to complete this process? There is no inverse. This matrix has no inverse. Next time you're having a mathematical conversation and somebody talks to you about a non-invertible matrix, this is the reason. If the determinant is 0, you cannot find an inverse. There is no inverse for the matrix. And that has implications in problems. But for us right now, we're just learning to find the inverses. And this one doesn't have an inverse. It's not possible when the determinant is 0. Because again, you cannot divide by 0. Remember in the last problem, we divided by 10? That's fine. You can divide by 10, but you cannot divide by 0. Okay. Awesome work. Make sure you do have your calculators by your side next time. We will definitely be using them. Have a great day.